Alright, let's talk about some different methods of grooving and parting off in the lathe. If you're following along with the hard copy of the textbook, we are on page 81. Alright, this is lesson 8. Now, the only difference between grooving and parting off is grooving does not actually cut the part off, so you can think of grooving as not going to x0 versus parting, which is going to x0. Now, there's two different ways to do this, okay? One of the key here is you could do it longhand method, so you can literally, place it in a Z location and then just plunge in the X at a specific feed rate and a specific depth. Or there's can cycles for it that allow actually pecking during this cycle, which helps you break the chip, especially when you're parting off a large diameter. It's very helpful. One thing to focus on here, and you'll see them mention this in the text, is where the tool 0 is very critical. So on this parting off example on page, let me get your page 83. If I do some notes on here, I just want to show you this. One of the issues is where do you set the tool? Which side of the tool are you setting 0? And that affects all of your Z positions for that tool. So if you set the tool here and the left-hand side of the tool is 0, then that is where all the Z moves are coming from. You'll see on the textbook they program the right-hand side of the tool. Okay, so all your Z moves come from here. So you've got to take into account the width of the grooving tool when you touch off the tool length offsets, whether it's the chuck, however you're setting off the tool length offsets, the width of the tool needs to be taken into account here with the Z moves. So remember that. Where you touch the tool off, where the tool offset comes from, whether it's the left or right hand side of the tool, is very critical. So remember that. All right. So as we continue through here, all right, this is just longhand. You'll see that they're just cutting in. They're going to position, okay, and then they're coming in and cutting past 0 right here. This is just a parting cycle, so right here is when they are actually parting off the workpiece, okay. If you take a look on this one, the actual Z position of how long the part will be is taken care of right here. So if we come up, all right, and I'll just clear those. The Z is taken care of right here. Here is the Z 2.0. Okay. Looks like they are going to Z minus 2.0, which means they are touching off the right-hand side of the cutter. All right. It's irrelevant which side of the cutter you want to touch off on. Just realize that it does matter for how you program. Okay. So as we continue through here, all right, we have an example. All right, we'll talk about that in a minute. I'm not really worried about this one. We're going to take care of it in the next one. Just shows you different examples. You can work through these. It's really not a big deal. It gives you some instructions. I'm not worried about it. That's just longhand. So again, they are literally just using X and Z moves, whether it's G1 to cut in, G00 to position, whatever, and just plunging in. That's fine if you're just doing simple grooves. But when you get into, let me continue here and get right into the can cycles. That is probably going to be new. As we get into can cycles, they become extremely helpful with G75, and that allows pecking and automatic widths of different grooves. Let's say you have to groove a 1/4 inch wide, with a 1/8 inch tool. You could actually use a G75 cycle and automatically create that width very quickly with minimal code. So as we continue through here, I'll give you a page reference. I'm just cycling through. Looks like in the hard copy text, we are on page 90. Pay attention here. So page 90 gets into the G75 cycle. Okay, and here's all your different parameters. All right, you have an X position, and that's going to be the diameter you create with the grooving tool here. Then we have a lot of other options here. Look, definitely focus right here on their example. It's very typical. You're creating a 3/4 inch diameter. Okay. Then it has the Z, all right, and a K. Now, the key here is that the Z is the furthest peck away from where you are. So the start point before you work with the can cycle, you need to be in the position for the first groove. Now, if the groove is just the width of the cutter, okay, let's say we're in this case using a 200 thousandths parting tool, then you don't need a Z value. Okay, it'll look like the example, we'll get there in a minute, on page 91, all right, which is they're parting off just by, you know, where they're going in the X diameter, but that is just a single groove, you know, go in, come out. This example, all right, from where we are to the Z location, all right, it'll create multiple grooves there. Okay, so if I'm drawing here, the first groove would be like right here. Then it's going to go over 30 thousandths each rip until it hits Z minus 0.332. All right, so it's not going to go in and go like this, all right, and create the groove width. It's going to go like this. And let me draw right here. If this is the groove, it's going to go in here, peck in. It's going to move over 30 thousandths, peck in, move over 30 thousandths, peck in. Okay, until it reaches Z minus 0.332. All right, so there's a lot of going on there with minimal code. Now, the I is a radial value peck depth. And that's really nice. You know, grooving's great, but you can get away with a lot when you're not going down to X0. But what happens is, it's like just like I showed you right here, it's going to peck each time. All right, and it's very fast. But that just breaks the chip, so you don't get the big, huge curls on the chip, which can bind up and cause, you know, if you're going to break a tool on the lathe, it's going to be a parting tool or a grooving tool. They are always ones that get damaged and broken. Okay, so let's take that into account. All right, those are the parameters for G75. All right, again, some of them are optional. If we clear this and talk about parting off, okay, and make sure you read this here. It tells you essentially what I just did right here. Okay, so that is for a groove. That top example is for a groove that is larger than the parting tool you're using or the grooving tool you're using. The G75 below is a just, you know, the grooving tool is going to go right in, okay? If this is the grooving tool is going to go straight in. There's no moves this way, okay? But the benefit of this versus longhand programming is that you're getting the peck cycles occurring. So this is excellent. Even if you're not parting off all the way, this is obviously parting off, but this will peck every 100th thou radially and break the chip. It's very, very helpful. All right, very easy Cannon cycle to understand why it's useful. Okay. Also, again, this gets into some of the Haas setting 22 as far as the pull-off amounts and things like that. But make sure you focus right here. Okay. Very important. All right. But these two cycles, Discriminator probably won't show you. Definitely you're going to need the simulators to see this. They are extremely useful, especially, you know, if the groove is wider than the tool, this makes it real simple, makes a lot less code, and the peck value, you know, the ability to peck on this is huge. The same as, you know, when we did the mill earlier and you're doing drilling cycles. To go Z minus Z up, Z minus Z up, that's a lot of code. G83 takes care of that. This is the same concept. All right? Then it gets through more examples of grooving. I recommend you do these. I'm not going to ask you to do them right now. Okay? What we'll work on is we will get right into threading. Okay? And we'll pause right here, and we will come back at page, I'll get you right here in the textbook, page 103. All right, now we can continue here. Again, page 103, lesson 9 on threading. One of the first cycles we're going to talk about is how to rough out your threads, and you could finish them here too, but spring passes will be talked about later on, is G76. Okay, so G76 relies on not only your input, but also some values that are either defaulted or setting parameters on the lathe. So you have an X value, okay, the X is the root diameter, and that is, you can get that out of the machinist handbook. Okay, the Z value here, let me note this for you. The Z value is where the threads are going to end, and we're going to end in the middle of this groove somewhere, so you can add a little bit for that. It's not really critical for this one. Okay, Then you see they end up using a K value. That is the height of the threads on one side. So if you look at, you know, threads like this, they're just talking about one side. It's radial. Okay? You have a D value, okay, which is the first pass cutting depth right here. And typically that can be increased more, you know, you can take a deeper first pass and then progressively get less as you're cutting using more of the tool. Okay? And that's really the key here. You of course have feed rate, and feed rate, if we clear this, feed rate is very similar to tapping. Sorry. But, alright. Right there. Nice thing about the lathe, okay, is that you don't have to worry about the RPMs as much because it's in feed per rev. So all you need to do is calculate the lead you want, okay, so one lead, right, and that is your feed rate. So in this case, it's 1 inch, you know, threads per inch. 1 divided by 11 is 0.90. Okay, 0.91. You want to be pretty accurate, so you want to go out, you know, a few decimal places. But that feed rate, you know, your RPM doesn't have to sync to it like it does on the mill. It's because the mill is in inches per minute. So basically, this one, you know, you can change the RPM initially to whatever you want. Okay, your feed will remain the same, which is nice. Now, the settings I was talking about earlier. There are thread finish allowance settings. A Haas setting 86, and there's also setting 99, which is the depth of the last cut. That defaults to 1 thou. Very rarely do I mess with those. There's a couple things you can do here. Instead of doing a thread finish allowance, you can see what it defaults to. You could really simply, instead of worrying about those settings, to help you if you don't run Haas machines, you can end up going in there, instead of going to X.513 in this case, 513.5, you could go to X515, and then you could do a separate, you know, G92 for a finish, which we'll talk about G92 in a minute. So it's up to you how you want to get that. Okay, if you want to leave a couple thou for finishing, then there's different ways to achieve that. Alright, but just to get the basics here, I'm not going to get too in depth. Now, the next one is G92, and basically this sort of just syncs up the spindle. So you have G92 going, you know, in X position, to go into a Z depth at a certain feed rate, and ignore the M24 for now. That's part about chamfering. I'm not worried about that. But the nice thing here is that G92 just essentially, it's like hitting the thread chasing, the threading lever on the manual machine. That's what it's doing. And then the additional passes, since this is modal, the depths are taken care of by separate X moves. So there's some power there. You don't want to do the whole thread this way, but you could. Okay, so typically, like in the book examples, they'll rough it out with G76, and then they will do a couple spring passes with G92. Okay, now, if you want to do pipe threads or taper threads, or if you're getting a taper in your thread, you want to get it out, you can add an I and work with I. All right, that is something we'll have to talk about more at the machine. But I is also a value if you get up in here. I is thread amount and taper. It's a radial value. Okay. So as we continue through here, all right, it gets into more information about M23 and 24. This is chamfering, and it's all controlled with setting 95 and 96. Don't worry about that. I'm not going to get into that here. We're just trying to get the basics of the 2 cycles down. Now, here's your example. It gets into what a spring pass is. This is sort of the block here that is sort of typical. You have a G76 roughing it, and then it gets into just a couple extra spring passes with G92. All right. As we continue through, it has a better breakdown here to me. So this is, just to get you on here, this is on page 108. It sort of breaks it down as you would, you know, the information you want to put into the cycle to create what you want. You get the root diameter, the X value. Okay? You get the Z depth. Gives you information. You get the K value, where it comes from. The D value. Okay? And then finally the feed rate, which we just talked about. Alright? And as we continue through here, pretty simple. All right, it gets into G92 again. All right, it talks about how it's modal, it's for simple threading. The issue here is that you can't take progressively less passes easily versus the G76 cycle. Okay, G92 you could, and Master can kick it out that way. There's not saying you can't, but it is easier to use G76. But they're both used, so you can pick what you want to do. Okay, the X values are simply controlled separately. Okay, each progressive X value. All right, goes right through that. Pretty simple to understand. Then it has an example. Okay, this 5/8 thread, which is what we were cutting before. Okay, and it walks you right through it. You know, facing it, roughing it with the G71 can cycle. All right. Then it finishes it with the G70, I think. Yep, on line 59. Then we get into cutting the groove, and they use a G75 for this. They use a 118 cutter. The groove is 1/8 of an inch, so they do have to take 2 passes. Okay, so good example there, what we just covered. Then it gets into the threading, and you'll see it just like what we just talked about. G76 sort of does, I mean, it does finish it, because it does have an X value of 513.5, but it does most of the roughing, and then you take 2 spring cuts with G92. So it uses all of them. Okay? Then finally, a part off. All right? And again, it is pecking. It is using G75 on line 129. This would be identical to just using G1, except for their pecking 100th out, which is nice for parting off. Alright, so the previous example was out of the Cam Instructor textbook. This is the Haas workbook. I think both are very good to cite. I do think that the Cam Instructor book is a little bit superior for this particular example, but they are both good. As whatever it takes to, whatever references I can give you to learn this material is what you need. So it goes over the G75 right here. Breaks it up for single pass and multiple pass, pecking, etc. Gets into the details on G76. I do like this example on page 110. The one thing that this does cite a little better are the settings in the background of the Haas controller, so just take that into account. It gets into more of the G76, the M2324, the chamfers, angle thread out, etc. And then it gets into a nice cheat sheet on page 112 and 113. I would highlight that. It gives you, it would be the maximum threading speeds, which are kind of important. Then a little cheat sheet for other information. The lead, the OD thread, or for the K values, given a certain pitch, which is kind of nice. And then it gets into just another example. Okay, which is nice to have. It also has the breakout from the machinist handbook, which you will need. For whatever thread, it just breaks it out, kind of what you would run right on a piece of paper, which is handy. And then it gets into the drilling, which you should already be familiar with from the milling machine, very similar. And then over on page 129, it gets into G92 for the simple threading, which I recommend, or what I want to see you do for your spring passes, because it's just an example to use both methods. So that's a quick reference out of the Haas programming workbook, and again, the main lecture was in the Cam Instructor book. So using these 2 references, hopefully you'll be able to grasp this. If you have any questions, please let me know, and thanks for watching.